Earth's shape is the only reason you're alive right now. Change it just a little, and oceans flood continents, gravity breaks, and civilization collapses overnight. Every planet in the universe is sculpted by gravity. But what if Earth hadn't ended up nearly round? What if it were hollow, cube-shaped, or even shaped like a donut? Today, we're exploring 7 terrifying shapes Earth could have been, the physics behind them, and exactly how each one might wipe us out. And one of these shapes wouldn't just destroy life, it could rip the planet itself apart. Before we get into nightmare worlds, we need one simple rule of physics. Large objects in space become spherical because gravity pulls matter equally toward the center. Once a body becomes massive enough, like Earth, its own gravity overwhelms the strength of rock, dragging everything into a near sphere called hydrostatic equilibrium. That's why Earth, the Moon, and even dwarf planets like Pluto look round. Earth isn't a perfect ball, it bulges slightly at the equator because of rotation, but that shape is remarkably stable. Remove that balance, and things get deadly. Imagine Earth shaped like a massive ring with a hole straight through the middle, wildly unstable. Gravity wouldn't pull toward a single center. Instead, it would tug sideways in strange directions. Oceans would slide toward the inner rim, creating planet-wide megatsunamis. The atmosphere? It would leak toward the hole, thinning the air across entire hemispheres. Weather systems would become uncontrollable. Some regions would experience perpetual hurricanes. Others, suffocating calm. Worst of all, computer simulations show such a planet would collapse under its own gravity, eventually snapping back into a sphere, releasing energies capable of sterilizing the surface. 2 planets fused together by a narrow land bridge. From space, it looks balanced. From the surface, gravity near the middle would weaken dramatically. Stand in the connecting region, and you'd feel almost weightless. Oceans would rush away from the center and pile up on both ends, flooding continents thousands of meters deep. Tectonic stresses would tear the crust apart. Megavolcanoes, super earthquakes, and the bridge connecting the 2 halves? It would likely collapse, splitting the planet into 2 separate worlds. Civilization wouldn't survive the first geological convulsion. A lopsided planet, one hemisphere heavier than the other. Gravity would be stronger on one side, pulling oceans, air, and even tectonic plates toward the heavy end. Entire seas migrate. Glaciers flow uphill. Atmospheric pressure differences spawn continent-scale storms. Over millions of years, mass redistribution would try to reshape the planet into a sphere, again triggering planet-wide volcanism in the process. Life might cling to small regions, but global stability? Gone. Physics says this one simply can't exist naturally. A disk the size of Earth would collapse into a sphere almost instantly. But suppose some impossible force held it flat. Gravity would point mostly toward the center, meaning oceans, air, and people all slide inward. The middle becomes a world ocean. The edges? Frozen wastelands with razor-thin air. Without curvature, the atmosphere escapes more easily into space. Radiation from the sun bombards the surface. Magnetic field weakens. Within geological time, ozone gone, oceans boiling, mass extinction. Yes, a cube. At the center of each face, gravity pulls straight down. But near the edges, you'd feel tilted like living on a slope forever. Water flows toward face centers, forming 6 enormous oceans, one on each side. Mountain ranges rise along edges taller than Everest. Weather systems smash into corners and stall, creating perpetual storm vortices. But the real danger? Stress concentration. Corners and edges would experience enormous internal forces. Earthquakes never stop. The crust fractures. Eventually, gravity wins, and the cube rounds itself violently. Every continent destroyed. A shell with empty space inside. Sounds exotic, but it's physically impossible for a rocky planet our size. Why? Because gravity would pull the shell inward. The crust collapses. Global implosion. Even if some miracle material kept it intact, Earth would lose much of its magnetic field generated by the molten outer core. No magnetic field means solar radiation stripping the atmosphere, DNA-damaging cosmic rays. Climate collapse, life becomes impossible long-term. Now, we leave planets behind. Imagine a disk thousands of kilometers wide orbiting a star. Not a ring, a solid plate. This is called an Alderson disk, a science fiction megastructure requiring more mass than entire solar systems. Gravity would be wildly uneven. Mountains taller than Olympus Mons form naturally. Oceans pool in vast central basins. But here's the killer. Such a structure is gravitationally unstable. Without constant active support, it would drift, fall toward the star, or collapse into itself. In the worst case, its mass could form a black hole. A single structural failure could doom everything living on its surface. Instantly, across all these shapes, one brutal truth keeps appearing. Gravity hates complexity. Large, rocky bodies naturally want to become spherical. Any extreme shape fights physics itself. And when physics wins, it does so with earthquakes, magma oceans, atmospheric loss, and planetary-scale destruction. Earth's shape isn't random. It's the reason long-term life is possible at all. Computer models used by planetary scientists show that even modest distortions in shape drastically alter plate tectonics, climate circulation, ocean stability, magnetic field generation, atmospheric retention. NASA simulations of planetary formation reveal that protoplanets violently reorganize themselves until reaching equilibrium. The rounder the world, the safer it becomes. Every odd geometry we explored today either collapses, one tears itself apart, loses its atmosphere, 3 or sterilizes its surface, 4, sometimes all 4. Here's the terrifying realization. Earth already experienced this chaos. Early in its history, molten and battered by asteroid impacts, our planet reshaped itself again and again. Only once it settled into its stable, rotating sphere. Did oceans persist? Did the magnetic field lock in? Did climate cycles stabilize? The shape beneath your feet isn't cosmetic. It is the final product of billions of years of cosmic violence. Change it, and Earth instantly becomes hostile. A donut Earth floods itself. A cube fractures endlessly. A hollow Earth loses its shield. A flat Earth can't even hold its air. A disk collapses into stellar catastrophe. Earth's near sphere is not boring. It is survival. Out of all the shapes a planet could take, we ended up on the one that lets forests grow, oceans stay liquid, and civilizations rise. And if you enjoyed the video, make sure to like and subscribe, and check out the channel to find more amazing and new videos.